All right, number 10 in 8A is one of these wheel spinning problems. And notice the point that we're spinning is directly to the right of the center of this rotation. So that's kind of the setup we want for measuring those theta reference angles that we've been using for these rotational problems. And this one, it's easy to figure out the radius since it's directly across. It's 5 because it goes from 2 to 7. And then we spun the wheel 27 degrees, right? So we learned that if this thing's centered at 0, 0, and we spin it 27 degrees, so centered at 0, 0, rotation of 27 degrees gives 5 times cosine 27, 5 times sine 27. Remember, when the radius was 1, it's just cos 27 sine 27. And then when the radius 5, it gets quintupled. Okay. But we're not centered at 0, 0. We're centered 2 units this way and 1 unit up. So what we really need to do is take that 5 cos 27, 5 sine 27, and move it by adding. Now, this notation, it might be new for some of you, but we're adding it by a vector. Vectors tell you how much to move. So this vector is saying move that point from 0, 0, move that center point from 0, 0, 2 units this way and 1 unit up, right? So it's not a complicated procedure. It's 5 cos 27 plus 2, comma, 5 sine 27 plus 1. Okay. And normally you're going to write the 2 and the 1 in front so that you don't accidentally confuse it with the angle 27 degrees. You don't accidentally say 29 and 28 degrees over here. So that the 1 would go in front here. 1 plus 5 sine 27. And then if you wanted a more kind of practical way of thinking about it, you can plug them into a calculator. I'm in radian mode, so I'm going to hit mode, come down here to degree, switch it over, second mode to quit. And then I'm going to do 2 plus 5 cosine 27. And I got 6.455-ish. And 1 plus 5 sine 27. 270. And then let's see, does that look about right? 6.5-ish and 3 and a bit. Yeah, that's about right. So that looks pretty good. Now, the second part of the question says, what if it's theta degrees instead of 27? So it's really the same exact process. The only thing that changes is we want to replace 27s with thetas in this expression right here. So if rotated by theta instead, by theta degrees, then we really get 2 plus 5 cos theta and 1 plus 5 sine theta. Right there. And that's sort of the key to this idea. And that works for any theta. It could be 192 degrees. It could be negative 75 degrees, which would be a clockwise rotation instead of counterclockwise. Okay, hope that helps a little bit.